Okay, I'm going to look at this problem 12174. This is actually in an older textbook, the 11th edition, so if you can get hold of that, you can have a look at this problem. It is a pulley problem, which is the absolute dependent motion. So we have this point here that's being pulled in by the motor, right? It's being pulled in by the motor, so it's going with at a velocity in that direction. Or rather, should I say, it's motion. It's going in that direction. Its movement is in that direction, and B is related to this point via this complicated pulley setup. Okay, so we want to know. It says here, determine the constant speed at which the cable at A must be drawn in by the motor, right? The speed that the motor is pulling that cable there, in order to hoist the load. Hoist, what does that mean? Hoist, to lift it up, right? To hoist the load at B 5 meters to hoist it 5 meters in how many seconds? 5 seconds. Okay, so what do we do? The first step is, remember, we're always trying to find the total length. That's always our first goal. So here we have from that point, so right, the cord goes like this, goes around there, right? So in order to get our total length, we first need to set up our datum. Where's a fixed point? We can use this as our fixed point. Okay, and there's reference line. And down here, sorry that it's overlapping with that other arrow, that will be our SB. Right, that's the position of this pulley. Because that pulley moves with the same motion as block B, that's our SB, that becomes our SB. Now can you see that that length, plus that length, plus that length, plus that length, are all SB? Okay, even though that's not technically the same lengths, if SB moves down or up, the change in these lengths will be exactly the same. So we have SB, 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 SB. So we can have 4 SB here. But we've forgotten about this one. There's our other one. And there is SA. Okay, so there is SA. From a fixed reference point to the motion of the point or the particle. Okay, so we got SB and SA. What would be the total length? The total length is going to be SA. It's going to be that there, SA, plus 1, 2, 3, 4. 4 SB equals total length. All right, then remember we're looking for velocities here. Determine the constant speed. Okay, we're looking for speed, so we need to take the derivative of this. We're going to get VA plus 4VB is 0. So the question is determine the constant speed of A. Okay, so we want A in terms of V, so we have VA is minus 4VB. So what this is saying is if VB moves up or down with 1 millimeter, then VA is going to move 4 times that motion, 4 times the change in position, 4 times the velocity, 4 times the acceleration of B, okay, because of this relationship. All right, but it would be going in the negative of A. All right, so what is VB? We're looking for VA. What is VB? Okay, the motor must hoist the load at B, this load, 5 meters in 5 seconds. So what's the speed there, the velocity? 5 meters in 5 seconds is 1 meter per second, right? And it must hoist it, which means it must go up, right? And we've already said that down is positive, so up would be negative. So we put minus 4. What is VB? We want VB to be 1, but we want VB to go up. So it must be minus 1. So VA is then 4 meters per second. So in order for block B to go up 1 meter per second, we need this point here to move to the right at 4 meters per second. Okay. So I hope that helps.